So let's just go through some of the demos. Before we work with plugins, if you like plugins, if you install a lot of plugins, your QGIS will take forever to start up, because the way plugins work is when you start QGIS, you'll go through each plugin and initialize the plugin. And that means if you have 100 plugins installed, QGIS will initialize 100 plugins and your QGIS will take 5 minutes to start. So a pro tip, which I always follow and I ask you to follow, is you can keep all the plugins installed, just go and disable them. Disable all the plugins till you need them. So you can say, I have 100 plugins, I'll keep everything disabled. That means my QGIS starts in just 1 second. And whenever I need this plugin, I'll go to my plugin manager and just enable that. And that's where it gets loaded. So make sure you keep the plugin disabled. I've worked with many people who get really frustrated because they say my QGIS takes 30 seconds to start. Well, disable the plugins, QGIS will start very fast. Secondly, if you install a lot of plugins, plugins are authored by third-party developers, not QGIS developers. They're not tested for quality. Some of those plugins are from amateur developers. Some of the plugins are also not tested for all the corner cases. And that means they may mess up your QGIS in ways that are not expected. So if you install some plugin, you got an error, it may go and change some of your settings, or it may go and change some configuration. And that means you'll always get this error when you start QGIS. So if you say, when I start QGIS, I always see this error pop up, I'm annoyed by this. Make sure you test your QGIS with a fresh profile. Plugins will typically mess up your QGIS install. So if you see your QGIS misbehaving, always try with a new profile. New profile will start QGIS without any plugins, without any changes, and typically that'll fix your problem. I also keep a fresh profile, one profile with all the plugins. I keep a fresh profile for writing my tutorials and everything, where I have a clean profile. I want QGIS to be as kind of close to factory setting as possible. I don't want to be customized by the plugins. So again, you can have different profiles for this. Okay, with that, some recommendations. These are the 2 plugins I always install in all my QGIS installs. And that's why I asked you during your pre-class survey. Most of you said you're familiar with this. QuickMapServices, we learned in this class as well, that allows you to access different base maps. Typically, all my projects will have the OSM base map, so you can use QuickMapServices to load a base map. QuickOSM is a plugin that allows you to query the OpenStreetMap database and download data, vector data from it. So if you want data for a project, this is a great database of free and open source data. You can download roads, building footprints, places, all of those. And link to a tutorial. If you're not familiar with QuickOSM, go and download this. You can download things like, I want to get point locations of all the bus stops in my city, or I want the location of all the EV charges in my city. All of those are there in OpenStreetMap. They may not be complete, but they'll give you a good head start for your project. And the buildings, if you're on building footprints, most cities have complete coverage of building footprints. You have really nice road network. You can download all of this using this plugin. Very simple to use, and you should be able to do this. So I'm not going to spend time doing the demos of this. You can go and check out the tutorial. The first plugin I want to demo is ORS Tools. This is my favorite plugin, useful for a lot of urban scale analysis. If you're do some network analysis, if you're working in cities and want to do GIS analysis, this allows you to do a lot of network analysis using OpenStreetMap data. And the way it works is, this is a service. This is a server that does all the computation. You don't have to download and install anything. You just sign up for an API key. It's a free service run by university. Just go and sign up for a free API key, input that into your plugin. And when you say compute, do some network analysis, that request will go on the server will compute that, and you only share the results back to you. Sometimes when you're doing a lot of data processing, there are limits of how fast you can call the service. So for example, if you're computing isochrones, you can only compute 40 per minute. And if your data has 100 features, after 40, you'll say error, rate limit exceeded, error. Keep the tool running. Once the 1 minute gets over, it'll compute the next 40. So just make sure that don't find that it's just able to do it. You just need to comply with the rate limit. Let's do a demo. So this is San Francisco, and these are the San Francisco BART stations. This is the metro stations in San Francisco. I want to show you, let's say we want to do some analysis and say, I want to live somewhere close to the BART station. I want to be within 10 minutes of walking distance from a BART station. And that's not as simple as doing a buffer. I can do a buffer of maybe 1 kilometer or half a kilometer, but that's not the same as walking 1 kilometer. What if I want to actually walk along the streets, respecting all the pedestrian restrictions and all the road networks? How far can I stay, which I can walk to each of these points within 10 minutes by walk, or maybe 20 minutes by car. How do I do this kind of analysis? And this requires you to have a good network. So you need to have a road network with the correct turn restrictions and topology, and then you have to compute those, do network analysis. This is a very complex thing to do, but once you install ORS tools, so this is the ORS tools that is installed, you can do something called isochrones. So let's say I'll do isochrones from point here. We'll say the mode I can do driving, cycling, or walking, do walking, and say I want to compute 10-minute isochrone and maybe a 15-minute isochrone, and run it. And again, I did not have to download any data. I just configured this and I get this as output. So you can see I've got this isochrone polygons where this is the region which I can reach in 10 minutes of walk. This is the region I can walk, I can be within a 15 minutes of walk. And again, you can see they are not circular. They are, along the network. And again, all of the data resides on the server. You don't need to do anything, just give the location and it's going to just work there. Interestingly, here it shows some stuff in the ocean because there are ferry routes. So again, you can probably be on a ferry and still reach here in 10 minutes. So again, this is some of the quirks of OpenStreetMap data. But again, this is something that you can do. If you're working in an urban setting, I almost never do buffers. I always do isochrones because they are more relevant. Imagine in this one side of the street, there was a big park. You can't drive through the park. So again, your driving distance will be different. So for urban regions, always do an isochrone. Now I have an easy way to do an isochrone using this. Similarly, you have a distance matrix. I have n start points and end points. Find the shortest path between each of those along the road network. This distance matrix will compute that for you. The next one, STAC API Browser. This is my current favorite plugin. If anybody asks me, I want to do remote sensing with QGIS, I'll say do not use QGIS for any remote sensing work because remote sensing data sets are typically very big, and QGIS, any desktop system is not suitable for doing this. You need to use a cloud-based system like Earth Engine or Planetary Computer or Python with Xarray and so on. But we have a pretty good intermediate solution now. So now it is possible to get work with remote sensing data within QGIS using this new protocol called STAC along with cloud optimized data. This is the plugin that allows you to query any catalog of satellite data using this standardized protocol. Most providers are now started publishing this data under this service. That means if Google is publishing some data, Microsoft is publishing some data, Amazon is publishing some data, they can follow this protocol and you can query all those catalogs using the same standard. And now there's a QGIS plugin that allows you to query any STAC API in a standardized way. Once you query this, you will get all the data set that matched your region in your query, and all of this data set will still be very large. If you take, for example, a Sentinel-2 image, each image might be 5 gigabytes, but you only want data for this region for this 5 bands. So you can say, instead of downloading the entire image, just send me the pixels that are there for my region. And it'll only stream the pixel directly from the cloud without you having to download entire files. There are newer cloud optimized data formats, such as cloud optimized GeoTIFF, ZAR, and other GeoParquet and other formats, which are able to stream data directly from the cloud to your server. This is similar to you having to download a movie before you watch even a small clip versus streaming the clip from Netflix. Right? So it's a similar protocol. Let's see how to do this. Let's open the STAC API Browser plugin. This plugin comes with a pre-configured repositories for open data sets. The Microsoft Planetary Computer provides a very extensive data catalog of very popular data sets. You can use that. There are other, Radiant Hub has one, and so on. If you find another STAC API repository, you can just add them here. We'll use the Microsoft one. You can do Landsat, Sentinel, MODIS, along with many other data sets. Let's get some land cover data. There's a data set called ESA World Cover. This is a global raster at 10-meter resolution, very large raster. If you were to go to the website and download, you have to go and download this entire tiles, and then only you can look at it. But with the STAC API browser, we can just say, I want ESA World Cover for this region, for the region that I'm viewing, for this time period. You can configure start and end date and say search. So we'll search the catalog for all the images that match this region. Once it matches, it says, okay, I found this tiles that match your region. Maybe I want to see this one. You can say view asset. I have land covers. I can just say, I want to if you download, you click download, download the entire file. I say I don't want to download, I just want to add that as a layer in QGIS. So I just say add the layer and done. You can see I have the ESA world cover data for this region streaming directly from the server. If I zoom in, it's going to get me the high resolution version of this. And you can see I'm started working with land cover data without downloading anything. And if I say I want to do some analysis, I want to digitize, I want to intersect this file is as good as a raster layer. You can do everything in this layer that you can do with raster layers. You can restyle it, you can intersect, you can clip it. So if I just say, I just want to land cover data for this city, get the polygon, clip it. And now you have a 10, 15 megabyte raster that you created without having to download this 5 gigabyte file. And you could just found it without actually going through the ESA world cover site, downloading and finding the tiles. And this works across Landsat, Sentinel, MODIS, all of those data sets. Super helpful. This is kind of changing the way we do Earth observation analysis in QGIS. So if I'm clipping it, you can see it's taking this data set that is hosted in the cloud, taking my extent and clipping it. So now I have a clipped version of this raster, which is a GeoTIFF file on my computer. And I could get this without having to download the tile and going through the internet and searching for it. And now this is just this file is just GeoTIFF file sitting on this. So again, you can do a lot of this very interesting things that were not possible in QGIS. If I loaded the whole ESA world cover raster and wanted to clip it, it's going to be a massive operation versus I could just clip it directly from the cloud. Next, Whitebox Tools. What if I told you that you could get 500 more tools in your toolbox for free? So this is what Whitebox Tools gives you. It's a system that was developed by Professor John Lindsay over the past few decades, and they have developed tools for doing dollar spatial analysis. So this is a system by itself. So you download Whitebox Tools and they have their own command line interface. You can run some commands into the analysis. These tools are also highly optimized. They are multi-threaded, they are C++. Recently, they said, let's integrate this with QGIS. So all of those tools can also be invoked from QGIS. They built the bridge through the processing toolbox. So now they have each processing algorithms for each of those tools that you can configure. It'll go and run the tool, and it can integrate with the rest of the tools. There's also a company behind it. So it's kind of a freemium product. You have subset of these tools free. Other, you have to subscribe and pay some money. Again, not very expensive, but again, just be aware that some of the tools, especially stuff that are kind of really advanced analysis, they are not available for free. So two-step installation. First, you need to install the plugin. So you go and install the Whitebox Tools for QGIS plugin, and then you install the Whitebox Tools itself. So you go to the website, download the Whitebox Tools binary. It'll be an exe file for Windows, bin file for Mac or Linux, and you just put it somewhere on the computer. Then you go to Whitebox Tools for QGIS and say, this is where my binary is. So when you run the tools, it'll call that binary. Just remember, when you kind of install this, when you go to download this, say, okay, I want to download this. I want to purchase this. Again, if you like the software, you can make a donation to them, but you can set it to 0 and download. So don't say that, don't think that you have to pay money to download this. You can say, I don't want to pay for it right now. I'll just use it free. It's a free software. But again, if you like it, if you use it, you can support the project by donating. This is the open code. So this is the free version. And then there is the extension version. So this is one as all the kind of premium tools, which you do purchase. And you can do things like you can do random forest regression, classification, do some advanced visualization and LiDAR analysis and so on. So some of the tools that are not easily available in any of the software. Our Pro license might have it, but it will cost you probably 10 times what this would cost you. So if you really need those tools, you can subscribe, but otherwise the free tools itself are pretty good. Let's do a demo. So first we have to go and install the Whitebox Tools plugin. So install Whitebox Tools for QGIS. Once it's installed, this will be added as a processing provider. So you can see now I have Whitebox Tools in my processing toolbox. I have tools, hundreds of tools that got added to my toolbox. But I cannot run it till I specify where are my tools. So I can go to my processing settings. In the providers, Whitebox Tools, I have to say, where is my executable? So I have to go and browse to the place where I've downloaded my Whitebox Tools. And in my case, I have it in my applications and WBT and show it the location for my Whitebox Tools. If you have an exe file, go and show the path to the exe file. Say, this is the file that you need to run for your Whitebox Tools. And once it's done, These tools can be run just as any of the processing tools. You can use them in models, you can use them as batch process. All of them will just look like this. So I find that Whitebox tools are an exception to my rule that if you have two tools that can do the same thing, always use the core tool. I found sometimes Whitebox tools are even faster. They're quite well implemented. So again, some operations, if you have two options and the QGIS core tool is slow, try the Whitebox tool. You have all the rows. I want to kind of smooth that. So smooth vectors. Let's run this. And you can see your smooth output. So you can see this one is the smooth version of this. So you can see some changes here. And again, you can see it was very fast. So do check out this plugin. I think this is really useful. Google Earth Engine. This is, again, I use a lot. I teach Google Earth Engine. This is Google's cloud-based system for doing remote sensing. Again, steep learning curve into learn how to write code. They provide a Python API, and there's a plugin that allows you to run Earth Engine code within QGIS. The advantage of this is not that you can use Earth Engine without coding. Many people, when they install the plugin, they say, oh, I can now run Earth Engine without coding. It's not that. This allows you to do coding within QGIS. So again, this is a different thing. You still need to know and learn Earth Engine, but typical workflow with Earth Engine is you do some analysis in Earth Engine, export your results, and then open in QGIS and see the result. Here, you can stream the data directly from Earth Engine to QGIS. So you can do stuff very quickly with your analysis. Some thing about authentication, if it doesn't work, we have documentation on how to fix it. I have a step-by-step tutorial, which is part of my other course, but I'm going to copy paste some code from that to show you. So the idea is we are going to look at some climate data. This is a very large climate data, which has got different climate models. And we want to create a map of temperatures in 2030, according to some of the model. So we have some model, and they said there are some predictions about model, and this data is an Earth Engine. This data is, I think, few terabytes in size, so really large data set, but Earth Engine can efficiently compute this and display the result. So we have Earth Engine plugins installed. I'll just go and enable those. Again, out of habit, I typically like to just disable stuff that I'm not immediately using, just to make my QGIS more responsive. So I'm going to turn on the Earth plugin and Globe Builder, which is the next step. So do this. And now my QGIS understands Earth Engine API. So I can write Earth Engine code in my QGIS Python console. So I have my QGIS Python console, and I can now write Earth Engine code. This is Earth Engine code. So you need to learn how to write this. So you can see my data for 2030 March, and doing some processing and say display the results in QGIS. So I run this, sending the request to Earth Engine. Earth Engine is computing my raster, and the raster will be then computed and streamed to QGIS. Okay, this is one level above that what we did earlier. It's not just files, it's actually doing some analysis, doing the scaling and computation, styling it, and now we get our image. So this is our image of average daily maximum air temperature in March. And we could get this directly in QGIS without having to export and do stuff. So explore this if you are using Earth Engine and you want to get your results in QGIS. I want to show you why this plugin is really valuable. Because if you did this analysis, the best way to display this is on a globe. Like this kind of data doesn't belong on a flat map. But Earth Engine doesn't allow, you can't create a globe in Earth Engine, but in QGIS you can. So that's the next plugin. I'm going to show you how to use this plugin called Globe Builder, which allows you to create globes. Globes are nothing but custom orthographic projections. So you can set a custom orthographic projection and take your map canvas into a globe. There are two options. You can say add globe to map. That means your canvas will turn into globe. It'll just set your project CRS to be a custom CRS, and it'll just look like a globe. Or you can add a globe to a layout. That means you can use that as a locator map. You might have seen some maps where you have a map and a coordinate map. It's saying this is the region on the globe which you're looking. If you want that kind of locator map, you can use this. Let's just see how to do this. I've installed the plugin, go to Globe Builder. It opens up this on the side. You can add some additional layers. They come with some additional data. We don't want this data. What kind of projection we want to set it to. So you can do an orthographic projection or some other one. So orthographic is the global one. Where do you want to center your globe? So we can say, I want to maybe show India as the focus. So I can just zoom to this and say, this should be the center of my globe. And maybe I want to set it to be a little higher in the latitude. So center of the current view. And what's your background color? Maybe I don't want a background color. Let's say I want to just be white and some other things, and say, okay, add globe to map. It's now setting this custom CRS, which is orthographic projection centered at the location which I chose. Just set my canvas to this, and now you have a globe. So your map canvas turns into a globe. Earth engine data gets reprojected to this globe, and now I have this, CMIP data analyzed and streamed into QGIS and created a globe. So if you see those globe maps, or if you have global data, use this plugin to easily create globes and display your data. Super helpful. And again, it's not a real globe. Remember, this is in GIS, we don't have a global, this is a projection. So it's an orthographic projection which simulates a globe. So you can't rotate it because it's just a one-sided view. It's a flat view of the Earth, which is simulating a globe. But again, this plugin allows you to set this and explore this. There are a lot of options, and you can add it to a layout. If you add it to a layout, you get a new print layout where you have a globe here, which can be used as an overview map. So again, super helpful for doing that as well. There's Raster Tracer. There's new AI stuff. I tested this, doesn't work that well. The Raster Tracer is still better than the AI stuff. And I have a list of other plugins which might be helpful to you.